Good morning, all of you. We have completed chapter number 1, and today we will start chapter number 2, work, energy, and power. Okay, so as we know that work is done when a force acting on a body produces displacement in it. But what is work actually in science? The term work and energy. The term work and energy are quite familiar to us, and we use these terms in many ways. In science, particularly in physics, these terms have very special meaning. For example, the term work is common use, means an activity. In common use means an activity, both mental and physical. But in physics, it is not so. So something is different in physics. The term energy is usually associated with work. Anyone who can do more work is said to be more energetic. Thus, the definition of energy is based on the definition of work. We use energy in various forms such as mechanical energy, electrical energy, magnetic energy, chemical energy, heat energy, and nuclear energy, etc. The use of chemical energy for doing work lies in the use of coal, oil, gas, and food. Okay, now work. Work is done when a force acting on a body produces displacement in it. When the displacement of the body, let's take an example for work. When a boy kicks a football to move, the boy is said to have done some work. That means there is a displacement between the boy and the ball. The ball displaces its original place and moves to another place. Similarly, here one example is given. A man while pushing a car, a cyclist while paddling a cycle, a boy going upstairs, a coolie lifting a load, all exerts a force which produces motion. So they do work. But suppose here in this example, a man tries to push a heavy stone, or a man tries to push a wall. They did not do any work scientifically in physics. Why? Because there is no displacement on the object which the man wants to push. That means here the man wants to push the wall. Whether there would be any displacement? No, there is no displacement. According to physics, there should be a displacement in the body. Here there is no displacement, so work is not done in this case. Now we have to measure the work. How we will measure the work? The amount of work done by a force is equal to the product of the force and the displacement of the point of application of the force in the direction of the force. Now, what is the formula of this work? Work equals to force into displacement of the point of application of the force in the direction of the force. That means here one example is given. If we apply force on A and on the object A, and it displaces some distance, and the distance is S, and it reach here at B. That means there is a displacement in the object, so work is said to be done over here. So what would be the formula of work? Work W is equals to force into displacement. That means work equals to force into displacement, or W equals to capital F into capital S. Now, work is a scalar quantity. Why work is a scalar quantity? If a force acts on a body and the body does not move, that is displacement is 0, then there will be no work. Where there will be no work? Here in this case there will be no work, but the man has done his work. He has put the pressure, he has put his force, but he didn't able to move the wall. Okay, now expression of work W equals to Fs cos theta. You have to read this formula. Okay, how it happens? Now, condition of work done by a force to be 0, where there would be a no displacement. From the above discussion, it is clear that the amount of work done by a force is 0 in the following situation: when there is no displacement. If there is no displacement, if the suppose this object doesn't move from its original position, then there will be no work done. That means there is no displacement, no work done. When the displacement is normal to the direction of force, when there is very normal directions displacement, that means theta equals to 90 degree. Suppose this happens to this. Suppose I have pulled a weight from here till here, again put it this here. So is there any displacement? No, there is no displacement. So in this case also there is no displacement. Now, work done by the force of gravity W equals to mgh. It is a formula of potential energy. Okay, this is a formula of potential energy. mgh, mass into gravity into height. Let a body of mass m be moved down through a vertical height h, either directly or through an inclined plane. The force of gravity on the body is F equals to mg acting vertically downwards, and the displacement in the direction of the force is S equals to h. Therefore, the work done by the force of gravity is W equals to Fs equals to mgh. Why this happens? Because as we know, suppose that this one is a ground and we have put a stone over here. Where would be the gravity? Its gravity would be here. It will pull downwards because the earth pulls it towards its center. Okay, so there is a vertical pull over here. So W equals to Fs equals to mgh. Now, units of work, SI unit. So SI unit of work is joule, 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 and it is abbreviated as capital S. Since work equals to force into displacement, therefore 1 joule equals to 1 Newton. That means it is a unit of force, 1 Newton, and displacement is the unit of 1 meter is the unit of displacement. Therefore 1 joule equals to 1 Newton into 1 meter. Thus 1 joule of work is said to be done when a force of 1 Newton displaces a body through a distance of 1 meter in its own direction. Bigger units of work are kilojoule, megajoule, gigajoule, where 1 kilojoule equals to 10 to the power 3 joule, 1 megajoule equals to 10 to the power 6 joule, and 1 gigajoule is equals to 10 to the power 9 joule. Now CGS unit. The CGS unit of work is erg, erg, where 1 erg equals to 1 dyne into 1 centimeter. Thus 1 erg of a work is said to be done when a force of 1 dyne displaces a body through a distance of 1 centimeter in its own direction. Now we have to read this relationship. Just learn this relationship. This is very important relationship for your entire exam. It will come in class 9, it will come in class 10 also. Okay, 1 joule equals to 10 to the power 7 erg. You have to find this relationship between joule and erg. Now, power. What is power? Power, the rate of doing a work is called power. Power means the rate of doing work is called power, and it is also a scalar quantity. That means how fast a work is done, how fast the work is done, and it is also measured. The power is measured equals to, if work W is done in time T, how much time taken to do a work. Suppose that I have done a work in 1 hour and another person has done the same work in half an hour. That means he is faster than me. That means he has much power than me. That is why he has done the work faster. Okay. Now, work is done in time T, then power P equals to work done by time taken. That means T, or P equals to W by T. That means work done by time taken is equals to power. Thus, power spent by a source depends on 2 factors. So there are 2 factors. So you have to read this one also. How many factors? On what factors the source of power depends? The amount of work done by the source, and number 2, the time taken by the source to do the said work. Where I have given an example that I have done a work in 1 hour and another person has done the same work in half an hour. Here time taken and the amount of work both comes. You have to read this example so that you will be able to understand. Now, units of power. If 1 joule of work, the SI unit of power is watt, and it is abbreviated as capital W. Capital W is the SI unit of power. If 1 joule of work is done in 1 second, the power spent is said to be 1 watt. That is 1 watt is equals to 1 joule by 1 second. According to this formula, this work done, power is equals to work done by time taken. This formula we have used over here, and we have got this. We have used this formula, power equals to work done by time taken. So what is power over here? 1 watt, and work done 1 joule, and time taken 1 second. So 1 joule per second. This is the rate of power. Now CGS unit, the CGS unit of power is erg per second. Relationship between SI unit and CGS unit is this. So you have to read this one also. One watt equals to 1 joule per second equals to 10 to the power 7 erg per second, and 1 HP equals to 746 watt. So what is the value of 1 HP? Whether you have heard this 1 HP, we have heard this in case of motors, in case of bikes, in case of motor vehicles. We have got this much HP power this vehicle is having, this car is having this much HP power, this motor, this generator is having this much HP power. So 1 HP means 746 watt. So 5 HP means 746 into 5, whatever the result, you will get that watt. Okay, you will get that power. Now difference between work and power you have to read. Now we will read about energy. What is energy? Anything that can do work is said to be energy. Okay, anything that can do work is said to have energy. The work of a body could do is a measure of its energy. A body possessing more energy can do more work. Thus, energy may be defined as the capacity of a body to do work. So, energy is the capacity to do work. So, what is energy? Energy is the capacity to do work. The SI unit of energy is joule. Quite often, a bigger unit called kilojoule is used. Energy is a scalar quantity. Again, energy is a scalar quantity. Now, the SI unit of energy is joule and the CGS unit is erg. Again, we have to find the relationship here. 1 joule equals to 10 to the power 7 joule, which we have learned earlier. Here we have learned. Now, that is why I have told you to learn that equation so that it will be used every time. Watt hour. The bigger unit of energy are watt hour, kilowatt hour, whatever it is. Watt hour. 1 watt hour is the energy spent by a source of power. 1 watt in 1 hour, that is 1 watt equals to 1 hour. So 1 watt, we have got the formula, we have got this value from here. One watt equals to 1 joule per second, and 1 hour equals to 3600 seconds. So 3600 joule equals to 3.6 kilojoule. Kilowatt hour, same we have to find, and we will get this equation. Now 1 calorie. So heat energy is usually measured in calorie. Now calorie. 1 calorie is the energy, that means heat required in raising the temperature of 1 gram of water from whatever the fixed degree to another fixed degree is related to as joule. Suppose that I have to boil a water, okay, and I have given some energy in it, so that I have to increase the temperature of the water, and it is at room temperature, that means suppose that 33 degree centigrade, and I have to increase it by 1 degree centigrade. Okay, so the energy which I will give is 1 calorie. Energy I will give to increase that temperature, that 1 degree temperature, and that 1 calorie is known as calorie of that one. Okay, now the energy of atomic particle is very small, so it is measured in electron volt. So what is electron volt? 1 E capital V is the energy gained by an electron when it is accelerated through a potential difference of 1 volt, that is 1 eV equals to charge of an electron into 1 volt. So charge of an electron, what is the charge of an electron? From where we will get? The charge of an electron is 1.6 into 10 to the power 9 coulomb into 1 volt. So 1.6 into 10 to the power 9 joule, 10 to the power 19 joule minus 19 joule, that is 1 eV equals to 1.6 into 10 to the power minus 19 joule. Okay, now it is predefined that charge on an electron is 1.6 into 10 to the power 19 coulomb. This one you have to learn, that how much charge is on an electron. So charge on an electron is 1.6 into 10 to the power minus 19 coulomb, and the volt is there. So you have to read this, differentiate between energy and power. After that you will see some examples, screen, this some numericals are there, and then you have to do this exercise 2a. Exercise 2a you will complete. Next day we'll start from here. different forms of energy, and there we will read about mechanical energy, where we will read kinetic energy and potential energy, different types of energies. Okay, today we have finished up to this. Next day we will start from 2b. Till then, thank you, goodbye.